Hello everyone. Couple of days before we have discussed about the rate of a chemical reaction. How to write the rate law for the chemical reaction. What is rate law? How it is determined numerically. Then what is order of the reaction? These all concepts we have discussed in detail. In this video we are going to discuss about molecularity of a chemical reaction. So let us discuss about molecularity of a chemical reaction. So to study molecularity of a chemical reaction, we must understand about elementary reactions. The reactions which takes place only in one step is called elementary reactions. The reaction which takes place only in one step is called elementary reaction. Say this, ozone gets degraded to molecular oxygen and atomic oxygen. Ethyl iodide undergoes chemical change to form ethene and hydroiodic acid. Nitrogen dioxide gets decomposed to nitric oxide and oxygen gas. These all reaction takes place only in one step, so they are called as elementary reactions. The reactions which takes place only in one step are called elementary reactions. So these all reactions are elementary reactions. On the contrary to that, complex reactions takes place in multiple steps, not in one step, more than one step. It completes in more than one step and constitutes a series of elementary reactions. Complex reactions constitutes series of elementary reactions. See here, NO2Cl undergoes decomposition to form NO2 and Cl2. This reaction takes place in two elementary reactions, in two steps. Each step is called as the elementary reaction. It completes in these two steps and each step is called as the elementary reactions. Elementary reaction. So here, when these two steps are added, we get the overall reaction. So this reaction is complex reaction. This reaction is complex reaction when this elementary reaction, when these steps are added, we get the overall reaction. So this overall reaction is obtained by summing up these two reactions. So this is a complex reaction which takes place in multiple steps, which constitute a series of elementary reactions in it. Molecularity is nothing but the number of reactant molecules taking part in the reaction. The total number of reactant molecules taking part in the reaction is called as molecularity of that reaction. Molecularity has significance only in elementary reaction. Molecularity has no meaning in case of complex reaction, because in case of complex reaction there are many elementary reactions and we cannot decide the molecularity in case of the complex reaction. We can decide the molecularity only in case of elementary reaction. So molecularity has significance only in elementary reaction. Molecularity has no meaning in complex reaction. So this is an elementary reaction. In this, two reactant molecules are involved. So its molecularity is 2, that is bimolecular. It is called bimolecular. So this reaction is bimolecular. So this reaction, two reactant molecules are involved. So this reaction is bimolecular reaction. Here only one molecule is involved. Its coefficient is 1. Only one molecule is involved. Only one reactant is involved. So it is unimolecular. This is unimolecular. Let us discuss about the order and molecularity at a time in case of an elementary reaction. So this is an elementary reaction. In this elementary reaction, the rate law for this reaction is given as rate is equal to K into concentration of NO2 square. Here, as the two reactants are involved, Therefore, the reaction is bimolecular. As two reactant molecules are involved, the reaction is bimolecular, and from the rate law, the order of the reaction is second order because the power of the concentration term is 2. So, the order of this reaction from the rate law is determined, that is 2. The order is 2, it means second order. So, molecularity is bimolecular, order is 2. So, molecularity is equal to 2 and order is equal to 2. So, by coincidence, this is a coincidence that here the molecularity and order are same. But this does not take place always. For the elementary reaction, this is the elementary reaction, rate law is written as. And we know that here only one reactant is involved. So the reaction is unimolecular. Molecularity is unimolecular and it is first order because the power of this concentration term is 1. So it is first order. However, this is not true in all cases. However, the molecularity and order of the reaction may or may not be same. Sometimes order and molecularity differs. Sometimes order and molecularity differs. Here by coincidence they are same. But they may or may not be same. So this reaction methyl acetate undergoes hydrolysis to form acetic acid and methanol. The rate log is written as in this way. So the power of this concentration term is 1. So the order is 1. Order is 1, it means it is first order. It is first order, and as two molecules are involved in this reaction, so the molecularity is bimolecular. Here molecularity and order are not same. Molecularity in this case is 2 and the order is 1. So here molecularity and order differ. So molecularity and order of the reaction may or may not be same. See the distinction between order and molecularity of a reaction. Order is experimentally determined property and molecularity it is theoretical entity. It is not experimentally determined just by observing a chemical reaction, that is elementary reaction. Just by observing the elementary reaction, just by noting the number of reactant molecules in the elementary reaction, we can decide the molecularity, but we cannot decide just by observing, just by the chemical equation. We cannot tell about the order of that chemical reaction. It should be experimentally studied. That reaction should be experimentally studied. Then only we can determine the order. It is the sum of the powers of the concentration terms. It is the sum of the powers of the concentration terms of the reactant, which appear in the rate equation or rate law, which appear in the rate law. This is the sum of the powers of the concentration terms in the rate law, and it is the number of reactant molecules taking part in elementary reaction. Don't consider complex reaction to decide the molecularity. So only elementary reaction. We can write molecularity only in case of elementary reaction, and it is the number of reactant molecules taking part in the elementary reaction. It may be an integer, fraction or 0. In the previous lecture, we have discussed about the order, and in that we have seen that some reactions have the order integer. In some cases, the order is fractional, and in some cases, the order is 0. So, we found this one in some reactions. So, order may be integer, fraction or 0, but the molecularity is always integer. The molecularity is always an integer that cannot be fraction or 0. It is always integer. So, in this way, we have discussed about the elementary and complex reactions, order and molecularity of elementary reaction. Thank you.